Welcome to our lesson on graph transformations. In this video, we'll learn how to transform a parent function into new functions by applying different operations. We'll use a visual approach to develop intuitive understanding of each transformation. Let's start with a parent function, y equals f of x. This will be our reference function to understand all transformations. For our example, we'll use a simple parabola, y equals x squared, as our parent function. Let's begin with vertical translations. When we add a positive constant c to our function, the graph shifts upward by c units. For example, if we have y equals f of x plus 3, every point on the original graph moves up by 3 units. The point rule is replace each point, x, y, with x, y plus 3. Similarly, when we subtract a constant c, the graph shifts downward by c units. For example, y equals f of x minus 2 shifts the graph down by 2 units. The point rule becomes replace x, y with x, y minus 2. Now, let's move on to horizontal translations. This is where things get a bit counterintuitive. When we replace x with x minus h in our function, the graph shifts right by h units. For example, y equals f of x minus 2 shifts the graph 2 units to the right. The point rule is replace x, y with x plus 2, y. Conversely, when we replace x with x plus h, the graph shifts left by h units. For instance, y equals f of x plus 1 shifts the graph 1 unit to the left. The point rule becomes replace x, y with x minus 1, y. Notice how this seems backward. A plus inside the function moves the graph left, while a minus inside moves it right. I like to remember this as the opposite effect rule for horizontal shifts. Next, let's explore vertical stretches and shrinks. When we multiply f of x by a positive constant, a greater than 1, we get a vertical stretch. For instance, y equals 2 times f of x stretches the graph vertically by a factor of 2. Each y-coordinate is multiplied by 2, so the point rule is replace xy with x2y. When we multiply by a constant between 0 and 1, we get a vertical shrink. For example, y equals 1/2 times f of x shrinks the graph vertically by a factor of 1/2. The point rule is replace xy with x 1/2 times y. Now, let's look at horizontal stretches and shrinks. Again, there's a counterintuitive relationship. When we replace x with a times x where is greater than 1, we get a horizontal shrink. For example, y equals f of 2x shrinks the graph horizontally by a factor of 2, or equivalently, compresses it toward the y-axis. The point rule is replace xy with x divided by 2, y. Conversely, when we replace x with a times x where it is between 0 and 1, we get a horizontal stretch. For instance, y equals f of x divided by 2 stretches the graph horizontally by a factor of 2, pulling it away from the y-axis. The point rule is replace xy with 2xy. Finally, let's examine reflections. When we multiply f of x by -1, we get a reflection across the x-axis. For example, y equals negative f of x flips the graph upside down. The point rule is replace xy with x negative y. When we replace x with negative x, we get a reflection across the y-axis. For example, y equals f of negative x creates a mirror image across the y-axis. The point rule is replace xy with negative xy. Now, let's put everything together and see how we can combine multiple transformations. When combining transformations, there's a specific order to follow. First, apply the transformations inside the function, horizontal shifts and stretches. Then apply those outside the function, vertical stretches and shifts. Let's consider a complex example, y equals -2 times f of 3 times x minus 1 plus 4. We apply the transformations in this order. 1. Shift right by 1 unit. Replace x with x minus 1. 2. Horizontal shrink by factor of 3. Replace x with 3x, 3. Vertical stretch by factor of 2, 4. Reflect across the x-axis. Multiply by -1, 5. Shift up by 4 units. The resulting graph shows all these transformations applied to our parent function. Let's summarize what we've learned. 1. Vertical translations. Y equals f of x plus c shifts up by c, while y equals f of x minus c shifts down by c. 2. Horizontal translations. Y equals f of x minus h shifts right by h, while y equals f of x plus h shifts left by h. 3. Vertical stretching / shrinking. Y equals a times f of x stretches vertically by a if it is greater than 1 and shrinks vertically if it is between 0 and 1. 4. Horizontal stretching / shrinking. Y equals f of a times x shrinks horizontally by a if it is greater than 1 and stretches horizontally if it is between 0 and 1. 5. Reflections. Y equals negative f of x reflects across the x-axis, while y equals f of negative x reflects across the y-axis. When combining transformations, work from the inside out, applying horizontal transformations first, then vertical ones. Understanding graph transformations allows you to sketch complex functions by breaking them down into simple transformations applied to basic parent functions. For example, if you know what y equals x squared looks like, you can easily sketch y equals 2 times x minus 3 squared plus 1 by applying the transformations we've learned. Practice these transformations with different parent functions like sine, cosine, exponential, and logarithmic functions to develop your graphing intuition. Thank you for watching this video on graph transformations.